All right. Well, good morning, everybody. It is Tuesday, May 4th. We are here at the Fairbanks Economic Development Corporation for the Energy for All Alaska Task Force. Happy Tuesday, everyone. Hope everyone had a good week last week. We also have Mr. Berggraf, of course. Our topic this morning is natural resources, particularly minerals, critical minerals, rare earths. Those hard rock minerals beyond simply gold, copper, silver, the ones we normally think of and track. Our guest is state geologist, Mr. Steve Masterman, and to walk us through the discussion. So, Mr. Masterman, if I may, please.
Yeah, thanks, Jomo. Yeah, good morning, everybody. And I don't need to say welcome from Fairbanks because I guess most of you are, if not all of you are in Fairbanks. So this is a presentation that I gave, I think it was last week, to the Natural Resources Committee of the Fairbanks Chamber. And they asked me to give a short update on critical minerals. And so some of this material is material that was presented to the Senate Resources Committee, Commissioner Feige and myself earlier in the legislative session. And then other parts of it were presented to the governor last week in a briefing that Commissioner and I gave to the governor on critical minerals. And then, other bits and pieces just pulled together from a variety of previous presentations, some of which were presented to the AMA and to other mineral conferences. There was a presentation given by the chief of our mineral resources section to the Prospectors and Developers Conference in Toronto, and also to Roundup in British Columbia. So bits and pieces from various places, but really the topic is critical minerals, and it's I guess a fairly a topic of some interest later. I kind of wanted to start off by going a little bit into some of the Fairbanks area mining activities and a couple little updates there. And because there's a couple of developments, I don't know if everybody's aware of, but that are pretty significant both for Fort Knox and for Pogo. So this is just a projection of the mineral production statewide for 2020. And you can see 500,000 tons of, this is in metal, 120,000 tons of lead, about 620,000 ounces of gold, that's down a little bit, and about 15.5 million ounces of silver. The gold production is probably going to go up a little bit here in the next few years. Fort Knox look like they're going to be developing this deposit, which they purchased a 70% interest in the Peak deposit last year for $94 million. And this is a gold deposit that's outside of Tetlin, just off the Alaska Highway. It's on Tetlin Village Corporation land. And it has a resource of a little over 1 million ounces. And Fort Knox are looking at bringing this into production in 2024 and trucking the ore to the Fort Knox mill and recovering the gold there. So there won't be an on-site mill. And this will add about 220,000 ounces a year to the Fort Knox production. So bringing them up into the 450, roughly, thousand ounces a year range, which is a pretty healthy amount of gold production. So that would be about a 5-year mine life down in Tetlin. And we'll keep the mill running at Fort Knox, which is good for all the people who work there. The other good piece of news in the Fairbanks area is around Pogo. And Pogo, was purchased by Northern Star Resources a couple of years ago, and they have been changing their mining method and upgrading the mill so they can increase their throughput. And they are looking at going to about 300,000 ounce per year from roughly 200,000 ounce per year production starting in a couple of years. So that will, bring probably more people to work, and increased production is always good. The other very positive thing for the Pogo area is the discovery that they made a few years ago. I think it was in 2016, maybe, to the northwest of the Pogo mine. They found an extension of the vein system across the Goodpaster River. And, you know, it's a similar, it looks like a similar sized vein system. It's the same style of mineralization, the same metallurgy. It's just basically a deeper extension of the system that they're mining on. And it looks like it's going to keep that mine in production for, I would say, decades. So I think that's a very positive thing for mining in the Fairbanks area. The other thing that's pretty positive for the interior is just the amount of exploration projects that are going on. And this is a map of the active exploration projects in 2020. And, you know, you can see, if you look around the state, the big cluster is in the interior. And it's no surprise, really, from a variety of factors. It's good road access, it's a lot of state land, and it's a mineral-rich part of the state, and it's mining friendly. So all of those things, I think, lead to, you know, increase in mining activity in the Fairbanks area. So it's really positive. If people aren't exploring, they're not going to be finding anything. And if they don't find anything, there will be no future mines. So all of those things I think are pretty positive. So I guess if anybody has a question, feel free to stop me and jump in. I think the intent is to be pretty informal here. So.
Yes, I would reiterate that. If you have any questions, please just take yourself off mute and go for it. Mr. Dotson?
So there was an article the other day about a outfit that staked some land down on Tenderfoot. Is that up here?
Yeah, Tenderfoot is down by the Richardson Mining District, which is just north of Delta on the north side of the Richardson Highway. And it's a gold.
I didn't see I'm not noticing the dot. Is it logged up here?
Let's see if I can find a laser pointer. So Delta would be right here. So it'd be right in this area about, if you can see where the laser pointer is.
Okay, thank you.
Okay, follow up, Mr. Dotson? We just want to know if it was there. We're good, Mr. Massman, please proceed.
So on the critical minerals, I guess this sort of began when China cut off the supply of rare earth elements to the rest of the world back in probably around 2010, 2011. China is really the major global producer and refiner of rare earth elements, and they flexed their political muscle there and their economic muscle by constraining supply. And as soon as they did, obviously the price went through the roof. A lot of people started exploring for rare earth elements, and there was a national recognition that we didn't want to be in that position where somebody could cut off supply of an essential commodity, either for military equipment or for the domestic economy. And so the government started to look at the issue of critical minerals and strategic and critical minerals. And I just put this slide up to show somewhat the difference between strategic and critical, and also, how dependent the United States is on foreign imports. So this is a chart from the 2019 U.S. Critical Minerals report. And it shows on the vertical axis, the percent of import reliance. So if the bars go all the way to the top, it's 100% imported. And so off on the right there, with aluminum, the right-hand most commodity, it's only imported at somewhere around 25%. And so that's not something that, I guess we don't import all of it, so it's perhaps not as important from the standpoint of somebody cutting off our supply. But it is a commodity that is critical for the the smooth running of the economy. And so that's where the elements on the right-hand side of this chart are called critical, because critical means that you need it, and strategic means that you don't have it. So the critical minerals are on the right-hand side of this chart in that we need it for our economy, and the strategic minerals are on the left-hand side of this chart in terms of we don't have it and we have to import it all. So as you have increasing import reliance, you move from just critical elements to strategic elements. The other thing on this chart is the colors of the bars represent the potential for those commodities in our state. And the red ones are currently being produced. And so right now we're only producing indium and germanium as byproducts from the Red Dog mine. The green ones are ones that we have produced in the past and could produce again in the future. Graphite is a very significant deposit on the Seward Peninsula called Graphite Creek, which is under development, or it's in, I guess, advanced exploration phase, and they're looking to develop that into a mine. Barite has been produced in the state and currently is being mined but not recovered at Red Dog and at Greens Creek. And the Palmer project in Southeast Alaska is looking to produce that as a product when they go into production. Antimony, tin has been mined, chromium, platinum group elements have been mined down in Platinum, Alaska. Tungsten's been mined in the Fairbanks area, among others. And then the blue elements are ones that geologically we have the potential to have economic deposits of in the state. And the gray ones are ones that geologically we're unlikely to have economic deposits of those. So potassium, potash, we don't have that, and aluminum, we don't have that here in Alaska. The other one that's not on this chart is helium, which we also don't have here. So this
is here, Jim.
Are the two gray ones that were up there, is there potential to mine those outside of China?
Yeah, so there is. Most of aluminum actually comes from, it's actually mined in Australia and in South America. And it's refined, it's refined a lot of different places, but a lot of it's actually refined in Iceland.
Yes.
Well, geothermal power. And potash is, there's some pretty big potash mines in friendly parts of the world. And there's actually some fairly sizable potash deposits in the lower 48 as well. Should, push come to shove and the nation need to actually mine them. They're just not economic under the current price structure.
Follow-up questions? Okay, very good.
This shows, this is again from a USGS publication, and just shows all of the critical minerals that were included by the USGS in their 2017 publication that defined the group of 35 elements and groups of elements that they called the critical mineral list. And this is that 35, and you can see the rare earth elements are one of those. The other group of elements on here are the platinum group metals, which are PGMs right here, platinum, palladium, etc. So the ones in the boxes here are ones that we either do have or have geological potential to have in our state. And the ones outside the boxes, aluminum, potash, and helium, I don't think it's reasonable to expect us to have deposits of those in Alaska. The other thing that on here, these are shaded by economic significance. And I just basically said if the nation's consumption of that commodity is greater than $100 million a year, then that's economically significant and something that we should use as a discriminant when we're doing our work to say, okay, what parts of the state are the economically significant commodities in, and because those are the ones that are more attractive from the state's perspective and probably from industry's perspective too. Some of these commodities are really small in terms of the national consumption. I think either scandium or strontium has a total US annual consumption of around $300,000 worth of metal. And so while it's a critical commodity from an economic standpoint, it's essentially meaningless. The big ones on here are in green, and the largest of those are the platinum group metals, which are, depending on the price, somewhere between 10 and $15 billion a year in the total US consumption. So when looking at these things, I think that's a good way to focus our efforts, because we don't want to spend our time and resources looking for something that is of very little interest.
Hey, Rich, I see you've taken yourself off of mute. Do you have a question?
Yeah, I have a curiosity question. It's about helium, and I don't know if this is an appropriate place to ask, but a long time ago, 30 years ago or more, there was a fellow I knew up at the university who was talking about providing a strategic helium reserve on the North Slope with the gas production, because I know helium is trapped in some of the capped gas deposits in the world, and that's where we sort of get our helium. Is that a reality? What happened to it? Did we squander it? Did it go somewhere? I mean, is it still there? Why can't we use that helium that's in natural gas deposits in Alaska?
We could. The helium has not gone anywhere. The natural gas that comes out with the oil is recycled and put back into the ground. But there's very low helium concentrations on the North Slope. So while there is some there, it's not in great quantity compared to some of the helium fields in the lower 48, where they may run 10, 12% helium in the gas that's in the ground. Up on the North Slope, it's considerably lower than that.
Well, I just learned something new today. Thanks, guys. Because I was wondering about helium on the list as again, kind of a mining commodity. Thank you.
The US, that one's an interesting one because the US is actually an exporter of helium. And so, I mean, I guess it's on there because of its application for the military, and I think it has a heavy application in kind of the nuclear industry. And so from the national, I guess, military strategy, then that places that commodity on the critical minerals list. The same with uranium, really. The United States has abundant uranium, but it's only on there because of the potential for it to be in need for a military application. So this slide breaks the critical minerals into commodities that are useful for solar and wind generation and for batteries and electronic vehicles, and the two together are in green. And I put this together really just to see, which commodities are of interest with regard to the current administration's focus on alternative energy. So, if you want to put a bunch of solar panels together, you need the commodities in yellow. If you want to put a bunch of batteries together and electronic vehicles, you need the commodities in blue. And on the lower right of this are also some of the sort of non-critical mineral components that go into those technologies. So for solar and wind, you need steel, copper, silver, silicon, zinc, cadmium, plastics. And I think the current administration recognizes that you can't have a bunch of solar panels and wind generators without having these commodities to make them out of. It's not like they just kind of spring out of nowhere. You have to produce the ingredients necessary to build the batteries or electronic vehicles or solar wind generators. And this administration seems to recognize that and has not been kind of attacking the production of these commodities. So I think that's helpful. So this is another way to look at the critical minerals. And here we group them by the gross US consumption value of dollars per year in the columns. And then in the two rows, we broke them into whether the trading partner is reliable or unreliable. And so from the Alaskan economic perspective, you want to be to the left of this column because those are the more economically significant commodities and will have a much bigger impact on our economy. And then from the national standpoint, you want to be in the top row because those are commodities that we are reliant upon, potentially adversarial or unreliable trading partners, such as many of these come from China or Russia, Democratic Republic of Congo, and the reliable partners would be places like Indonesia, Australia, Mexico, Canada, Europe. So the nation is, I guess the federal government is looking at something like this and saying, okay, so if we wanted to have a stockpile of commodities that we may not be able to get if we get into an adversarial situation, the ones in the upper right-hand corner of this box would be the ones you want to stockpile. The ones in the lower left are things that you would try to enter into trading relationships with foreign countries for. And the ones in the upper left are the ones that really you want to be stimulating domestic production of, because you're not going to be able to stockpile commodities of, that are in the billions of dollars range or needed in large quantity. And so those are the ones, again, to focus on from the standpoint of domestic production. So the US government's really approaching this in a multi-faceted way, stockpiling some things, looking to establish trading relationships with reliable or stable nations for other commodities, and then stimulating domestic production where necessary. And there's a variety of activities being undertaken to stimulate that domestic production. And that's sort of where we come in.
So Steve, there was a story. There was a story on NPR, I believe it was last week, regarding processing. I think we're going to end up getting there during this presentation or discussion of processing, because we have all these things and in abundance. It just seems that the sticky wicket is the cost of turning them into these pure metals that can be used for industrial purposes. But there was a story on it on NPR that, again, a couple of outfits were going to be jumping into the game.
Yeah, domestic processing facilities and capabilities have languished. The vast majority of that is done overseas, and that's part of the issue, And for example, the germanium and indium are mined at Red Dog, but they, along with the zinc and the lead and the silver, are shipped to smelters in Korea and Belgium and Canada. And there the raw metals are produced, and then from there they go to refineries that are somewhere else. And at those refineries, the germanium and indium will be separated out and then be available for sale. But it's a very complex and long chain of shipping and smelting and refining and processing to get to a final product. And those commodities travel the world sometimes repeatedly before they are in a final form that can be consumed by a manufacturer. So that's definitely part of the problem. And stimulating the refining and smelting of those materials domestically is, that's something the federal government's definitely paying attention to. But there are reasons that those things moved overseas, and environmental regulations may not be as stringent overseas. Price of labor may be cheaper, and that when cheaper to produce it, that's where it's going to go to.
Thank you, sir. Director Florence, you had raised your hand. Did your question get answered?
I was just going to ask about what drove the processing and refining overseas, and Steve answered it.
Okay.
Yeah, I think largely I would say it was environmental costs and labor costs. Smelters are not environmentally friendly things, generally speaking. You're roasting off the sulfur, producing a lot of sulfur dioxide, which I guess they use to make gypsum, which is in sheetrock. So there are some byproducts there, but there's a lot of metals that come out, and there's a number of Superfund sites around the nation that are at previous smelter sites. So the industry kind of got a black eye from the environmental standpoint. And in the 1980s, with all of the new environmental regulations, that put a lot of smelters out of business, and they moved overseas.
Again, I think we'll end up having a bit more of this discussion as we near the end of the presentation, but thank you, sir. Okay, thanks.
Yeah.
Please proceed.
So looking at Alaska, where are the critical minerals? And that's the $64,000 question, I guess. So this is a map from a report that was put out by the USGS and ourselves in 2016 that looked at the potential for these commodities across the state. And this is by drainage basins. So all these little areas are individual drainage basins. And this is a map showing the potential uncertainty for rare earth elements, thorium, yttrium, niobium, uranium, and zirconium across our state based on the geology, the known mineral occurrences, and the stream sediment geochemistry. And so these maps were put together for about a half of the critical minerals. Obviously, the hotter colors are the places that the current knowledge indicates are favorable for these critical minerals. So if you were to go look for rare earth elements, you'd probably want to start in the bright red areas where there's high potential and there's a fairly high degree of certainty that those metals will be present. So you can readily see the, parts of Southeast Alaska, the Yukon-Town uplands, broadly speaking, the Alaska Range, parts of the Seward Peninsula, and then kind of the Ray Mountains, Ruby Mountain area that straddles the Dalton Highway. Those are the places that light up for rare earth elements. And the Bocan Mountain deposit is in Southeast Alaska. I think it's right down in here. And in the interior, we have rare earth mineralization known in the Tofty area, associated with some carbonatites there, and at Roy Mountain in the Steese Recreation Area, associated with the syenite complex there, and also down in the southeastern part of the upland down by Mount Farewell. On the Alaska Range here, there's a number of prospects, rare earth element prospects out here. There's some major placer occurrences with rare earth elements, and the same, there's a series of placer occurrences of rare earths in the Ray Mountains as well from weathering of old granites up there. So we took all of those maps and combined them into a single map using ArcGIS just to say, okay, so we've got, 16 of these maps. How do we see if we wanted to go do some work that would provide information for all of the critical minerals, where would that be? So we did a little bit of a GIS exercise and basically came up with this map. And it's a heat map showing sort of the cumulative distribution of high potential, high certainty areas for the 16 critical minerals that have been covered by those maps. And, if you want to go look for or produce information that would help with the exploration for critical minerals, then obviously you want to put that money where it's going to do the most good. And from our standpoint, those would be the red areas. Now, if you were to go look for one commodity individually, this would change, but we're looking at doing or providing information that would help with the exploration of all the commodities. So that helped us define these what we call critical mineral belts. And those are the areas that sort of have a pinkish reddish outline there that are a little hard to see on here, but there's 7 of them, and you'll see those showing up in some of the other figures as we go through here. So there's a few commodities that are pretty significant economically that are not on here: barium, beryllium, particularly antimony, I guess, magnesium, graphite, fluorspar perhaps, that are very much present in the state. I don't know that this map will change that much with the addition of those commodities. It'll change some, but I don't think really the broad areas are going to change that much. So one of the things that is really important to recognize with the location of critical minerals, the majority of them are produced as a byproduct of the production of more economically significant commodities. So like at Red Dog, they're producing indium and germanium up there, but those are strictly as a byproduct from the production of lead, zinc, silver. And if you were mining the lead, zinc, silver, you'd never have enough economic benefit to produce the indium and germanium. And that's the same for, I would say, 3/4 of the critical minerals, that they are strictly byproducts or co-products. So some other examples of that would be pebble. If pebble were to go into production, it's, the major economics there are copper, gold, molybdenum, but it also has palladium, which is one of the platinum group metals, and rhenium, and that's another critical mineral. So those would be recovered as a byproduct. Bornite has cobalt. Right now, bornite's really a copper mine. The bornite would not be produced unless there's some economic or some metallurgical work done to help them recover the cobalt, because it reports to pyrite, which would not be recovered in the mill with the copper minerals. So right now, as that stands, that one wouldn't be produced. Palmer deposit in Southeast Alaska is a massive sulfide deposit that's really going to produce copper, zinc, silver, but it has a lot of barite associated with it, and that barite would be produced. So just a few examples of how the critical minerals are a byproduct of more economically significant commodities. And so all the work that we do to help define where the critical minerals are in our state can be used and will be used to locate the more economically significant commodities that those critical minerals are associated with, like the zinc, lead, silver, and gold. And to me, that's that's an often overlooked but really critical point. So what have we been doing at DGGS? And the next couple maps go through the three basic data types that we try to produce to help define where these critical mineral resources or other mineral resources are in our state. And those are geologic maps, geophysical surveys, and geochemical information. And this is—
Hey, Steve. Hi. So I just want to, I'm not trying to be rude, and I'm glad we got here. I just want to remind you, note the time. I believe that you said that you might have a hard stop. And so I just wanted to note it.
Yeah, thanks. My hard stop got deleted. So as long as
good.
I'm rattling on too far. Yeah. No, I'm good.
Then let's go deep and long. Thanks, boss. All right.
I got all morning. So this is a map showing all of the inch to a mile geology maps that have been completed in our state. Some of them need to be redone because they're old and our understanding has moved on. But this is everything that's been done since Alaska was purchased from Russia. And there's not a lot of green on that map. There's a lot of gray on that map. So there's a lot of places still to map. Inside those reddish pinkish critical mineral belts, there's almost 400,000 square kilometers to map. And right now we're geologically mapping about 4,000 square kilometers a year. So we have about 100 years of work to just finish those pink areas off. And the rest of it, you know, it's another few hundred years. So job security, I guess. We mapped an area the size of Arizona, but we're a lot bigger than Arizona. We're about 5 times the size. So we're only about 20% mapped at that scale. This is showing.
Actually, Steve, we have a question for Mr. Burgraff.
Yep.
Steve, I'd just like to comment, you guys have been doing a great job over the years, and Alaska has such potential, and we're hopeful that with what's happened in the world situation, that it's going to allow us to be able to start developing some of those resources. You know, the graphite is one big item. I've worked up in an area off the Hall Road, which has a lot of antimony. And, you know, we have such potential, and I'm hopeful that that potential is going to be able to develop.
Yeah, you're not alone there, Roger. Yeah, thanks for that. So one of the things that we have prioritized these areas, and we're currently working in the interior, and we hope that if our funding stays as it is, we will finish mapping geologically the area between the Yukon and Tanana rivers in about the next decade. So that would fill that area in, and that's one of the highest priorities for us. And obviously not just for critical minerals, but it's obviously got a lot of gold and it has some other resources in there too. So this is a map showing airborne magnetic surveys, and you can see that we have, or we will have, completely flown the Yukon Tanana upland by the end of FY22. And most of that is being funded by the USGS. Right now, the USGS is funding the geologic mapping and geophysical surveys to the tune of a little over $1 million a year. And we have 2 surveys that were under contract last summer, but people couldn't come because of COVID. Looks like one of them is coming here this month, and the other one is hopefully going to be here this month. And then the 3rd survey, we're just getting the contract issued right now. Again, about 400,000 square kilometers to do, but this goes a little bit faster. And so, yeah, we're done with the Yukon Tanana, then we're going to move on to the next area. And that next area is yet to be determined in I guess, finally, but we're going to be having that conversation this month.
Mr. Masterman, may I ask a bonehead question? How does the aerial surveying work? Is it like flying around with a giant metal detector? And how does it differentiate between different substances?
So that's great question. So there's a couple different ways to collect airborne geophysical data. One is with a helicopter, where you have the sensor on a long line underneath the helicopter, and you fly, in lines across the countryside, and you go up and down as you go over the hills. And that's called a draped survey. And typically, that's a pretty expensive way to go, but those are usually done by industry when they're looking at collecting very detailed information over a small area. And these surveys are being flown by a fixed wing aircraft that have the instruments on board. And in this particular map, this is looking at the magnetic signature of the rocks underneath the aircraft. So it's just telling you how magnetic those materials are. And different rocks have different magnetic signatures. Different mineral deposits have different magnetic signatures as well. And so you're looking for patterns in that data to help you understand the distribution of the rocks. The other types of data these systems can collect is radiometric data. So looking at how radioactive the rocks are. And that can help you look for, obviously for uranium, thorium as their radioactive elements, but other rare earth elements are often associated with uranium, thorium. It can help you understand the types of granite that you're dealing with. And then the third kind of information is electromagnetic information, and that looks at how resistive or conductive the rocks are. And that, again, can tell you a lot about the geology. And so if we have all three of those geophysical data layers, we can really see what's happening through the soil pretty well. And I don't have an example of that up on screen, but there's some great examples that show, major faults, the difference in intrusive rocks, the structure of the metamorphic rocks or the sediments. You can see folding and faulting. It really helps understand the geology, and it helps locate the mineral occurrences. So it's a very vital data set.
Thank you. Thank you. I've always wondered that. So thank you very much.
The third leg of our mineral exploration stool is stream sediment sampling information. This is a map showing all of the stream sediment samples that have been collected across our state by the USGS primarily. And this was mostly done in the 60s and 70s under the NURI and AMRAP programs. And they were analyzed at that time with the best available analyses, but by today's standard, those are incredibly crude analyses and were not for the full suite of elements. And so we are going to go through and reanalyze the stream sediment samples from the critical mineral belts with modern analytical techniques for a full suite of elements. And that is going to be incredibly helpful when you combine that with the geology and the geophysics. You really start to understand the trends of the mineral commodities where they are, and is a great tool for industry to be able to hone in on mineral resources. And this is a web tool that we launched a little over a week ago. It's the first round of data from the Yukon Towner Upland. And this is just a screenshot from that web app. It's I have the stream sediment data turned on. Those little dots, different sizes indicate relative metal content. Big dots, more metal. And this is for rare earth elements. So you can turn on any of the commodities that we analyzed for: gold, arsenic, molybdenum, copper, nickel, chrome, you name it, they're all there. And you can turn it on top of the geology, the satellite imagery, land status, geophysics, and we are going to import into here a couple of other layers, mineral occurrences, and I can see how active mining claims would be a really nice thing to have on here, so you could readily see, you know, if an area has already been staked or not. This is going to be a well-used tool, and it's just one way that we try to make the data available to everybody. And like I say, this has been a very recent launch, and as we add data and build it out, I think this will be something that will help bring foreign companies here to explore our state, which is very beneficial. We want to have a very active and aggressive exploration industry here.
I will tell you, Roger, our resident miner, real miner, he's nodding so hard, I think he's going to fall out of his chair. Thank you. Yeah, this is an enormous, amazing resource. Please proceed.
Yeah, I spend too much time looking at that. Yeah, I just love this stuff. It's really valuable. And you know, one of the things that's really great about this, I think, and Roger will pick up on this, is this is a poor man's exploration system. So if we load the geochemistry, the geology, the land status, the average prospector can go in here and, you know, and have all of the modern tools at their disposal to make, to go prospecting. Whereas, you know, companies could do this, but the average prospector doesn't have either the software or perhaps not the capacity to do it. So this really puts the information at their fingertips, and I just think that's great.
Agreed. Thank you.
This is just showing a zoom in of the Yukon-Tana area geophysical surveys. The green surveys are ones that were flown previously. The FY19 is one that was contracted to an Australian company, and last summer they couldn't get out of Australia, so they couldn't come here to fly the survey. And the blue areas were contracted to a Canadian company, and they also couldn't get here last summer for a variety of reasons, but they are going to be here this month. And then the pink areas were some helicopter surveys that we partially funded with state funds and then funded the rest of with industry funds in the immediate area around Pogo. So with the kind of the light blue outline, we'll have this covered. Hopefully this summer. If not this summer, we will get the rest of it flown next summer. And then we will combine all these surveys together into a single geophysical data set. And that will be available through our website. So it's great to see us painting the state with this kinds of information. This is just another view of the Yukon-Tana upland showing the stream sediment geochemistry. This is chrome in this case. And again, it just, you know, it doesn't take a rocket scientist to go, oh, look, there's a bunch of big dots right there. What's going on, you know? And one of our concerns when we were collecting this information was that somehow the samples would have got mixed up, or the sample numbers wouldn't be, you know, wouldn't have been kept over the 40 or 50 years. But it seems like you can see from this map that there are clusters of high values which correspond to the geology fairly well. So we have a pretty high degree of confidence that these samples are good, that they are where they say they are, and that the metal values are reflecting what's actually in place. And that's really great. So this is a slide showing all of the active mines and some of the advanced exploration projects or the development projects and the critical minerals that they contain. And so, for example, Fort Knox contains tungsten, very small amounts of tin, very small amounts of tellurium, bismuth, arsenic, and antimony. Currently, none of those are being recovered by the mill. So they're being mined, they're going through the mill or the heap leach, and they're either going out to the tailing pile or they're staying on the heap leach. Same with Pogo, none of those critical minerals are being recovered. Same with Greens Creek. At Red Dog in the northwest there, 2 of those are being recovered. Gallium and barium are not. And so, you know, one of the things this sort of brings up is, you know, why aren't these commodities being produced when they're being mined? And the basic reason is they're not economic for the mine to recover those commodities. And so they're going out in the tailings pond. And that's a huge opportunity, obviously, from a national security standpoint. If we could just recover the metals that are going through our existing mines, we'd go a long way towards reducing our import reliance. And unfortunately, the kind of research necessary to do this work was terminated when the U.S. Bureau of Mines was dissolved in the 1990s. And since then, really nobody's been doing any metallurgical research, any federally funded metallurgical research. And so, you know, we've fallen behind. And that's a big gap in my mind, in something the federal government should be addressing and hopefully will address. You know, if we can find metallurgical solutions that make the recovery of these metals more economic, then a lot more of them will be produced, and that would be beneficial. So, moving on to some things that the federal government is doing. The Department of Energy has recently moved fairly aggressively into the critical minerals world, and that's a good thing in many ways. And they started this by issuing funding opportunity last, I think it was August maybe, and it was called that Core CM, and that stands for Carbon Ore Critical Minerals. And so what they want to do is to look at rare earth elements and critical minerals associated with coal basins across the nation, and any critical mineral opportunities associated with oil and gas as well. And they, in their funding solicitation, they called out Alaska as one of the basins that they were interested in, and also stressed the need for applicants to work with state geological surveys. So I picked up the phone and got a hold of Brent Sheets up at UAF, or Brent got a hold of me. I don't remember which one it was. And we worked together with a whole large group of people and submitted an application to Department of Energy to assess the coal deposits and the associated rock units, and then also the deeper oil and gas systems in Alaska for their potential to host critical minerals. And we submitted our grant application in December, and we just found out last week that we were successful. So we will be working on this probably starting in June for the next 2 years. And an interesting thing about this is that the original solicitation had 3 phases, and we applied for phase 1, and the intent was that there was going to be a down select to advance to phase 2, and again, a down select to phase 3. And phase 1 is sort of resource characterization. Phase 2 crudely speaking, is pilot plant development to recover the metals and or bench scale, and then phase 3 would be sort of pilot plant scale. And apparently there's going to be no down select to phase 2. So if there is a phase 2, I guess we'll be working on that phase as well. So that's pretty exciting. One part that's yet to be kind of worked out at the federal level is how Department of Energy and the USGS are parsing out the critical mineral resource characterization, I guess. Typically, this sort of work has been done by USGS, and there's a little bit of turf associated with who's doing what. But I think if the Department of Energy stays kind of on the energy side of things and leaves the hard rock part of it to the USGS, then everything will be okay. The USGS has a critical minerals project of their own. It's called Earth MRI, and it's that project that is funding our work in the Yukon Town Uplands and elsewhere. So also last year, Department of Energy solicited a request for information for, what should they be looking at in terms of critical minerals? What are the gaps? What are the essential aspects that DOE should be trying to address with their research capability? So they have really 4 areas that they wanted to get information on: resource characterization, technology development, sustainable resource extraction. And by that, they really meant looking at extracting from waste streams of current mining operations, from reprocessing of tailings, and also from enhanced extraction of current operations. So there's some room in there, if they choose to do that, to look at some of the issues we're facing with recovery, say, of tungsten and bismuth at Fort Knox. How can that be made economic? So those resources are not put into the tailings pile, but are recovered and made available. Again, looking at extractive metallurgy, and then looking at the whole supply chain, international engagement for developing those relationships with friendly nations so that we can ensure a stable supply. What can they do on a policy level nationally to address, mining and processing of these materials where the environmental laws may not be as stringent? Are there tariffs that need to be put in place? Are there ways that they can, encourage the domestic production through economic incentives? So they were looking for a whole bunch of things. And one of the things that we suggested as part of our response was that they fund a critical mineral research institute at University of Alaska Fairbanks, because UAF has a lot of the pieces in place already. They have the Geophysical Institute, which is obviously really great top-notch scientists that could tackle some of the issues of resource characterization, looking at the technology for flying geophysical surveys faster, better, more detailed, flying hyperspectral surveys. They've got the Mineral Industry Research Lab that could look at some of the metallurgical components. They've got economists. They already have the Arctic Energy Office, so they have a DOE presence up there. They have the Geology Department. They have the Cold Region Engineering Laboratory, the Cold Climate Housing Research Center. So they've got a bunch of different pieces that could be brought together. Anyway, that was something that we suggested, and we don't know if it's going to go anywhere. The other thing about Department of Energy is they started a Office of Mineral Sustainability last year, and that was a big development for them. And it's unclear how that's going to play in terms of the whole sphere of metallurgical work that needs to be done. If they're going to just focus on carbon-related ores, that's a pretty small part of it. Somebody needs to pick up the whole metallurgical piece so that people are helping, the hard metal mines with the metallurgical work and the economics, or improving the economics of mineral recovery. So if these guys are just going to look at the carbon related ores, it's going to leave a big part of it untouched. And that, I think, is a problem that needs to be addressed, or at least ironed out.
Hey, Steve, before you leave that slide, we do have a question from Rich. Rich?
Yeah, can you hear me?
Yes, sir.
Well, it's a long way back now, but there's a lot of indications when you're talking about mining from coal-associated things. And just a curiosity, there's a lot of concern about the amount of coal ash that's being produced. And I know there's a lot of residual mineralizations in coal. Is it really a feasible idea to mine coal ash and get some of the, there's some heavy metals in there and things like that? Is that, rather than just dumping it somewhere and having heavy metal pollution somewhere, can you really mine coal from that aspect?
Yeah, it's a great question, and it's something that has had quite a lot of work done on it already, even here in Alaska. And so the coal itself and the associated fine grained sediments, the clays and the ashes, do absorb rare earth elements that are moving the groundwater. So like in our state, if you have an area where the uplands contain a lot of rare earth elements, then a small amount of those will be dissolved and get into the groundwater system. And those can be leached out of the groundwater and concentrated in the clays that are often associated with the coal seams and in the coal itself. And so when you burn the coal, they get concentrated in the ash. And there are technologies that are being worked on by the Department of Energy to leach those metals out of the coal ash and recover them. And they're very interested in finding, because those technologies are I don't think they're off the shelf, but they work. And so that's part of the reason for their wanting to know, where are the coal seams that have high concentrations of rare earth elements, and are those coal seams amenable to this kind of recovery technology? So right now, some work has been done by University of Alaska Fairbanks on the Healy coals, but apparently there are other coals in the state that have a significant amount of rare earth elements in the ash. Up in the Ray Mountains, there was some work done by the Bureau of Mines, I think it was, that had well over 1% of rare earth elements in the ash. And sort of the cutoff of interest for Department of Energy is 300 parts per million, which, over 1% is 10,000 parts per million. So that coal is very elevated in rare earth elements, and so would be of considerable interest if it were being used for the production of rare earth elements. So yeah, there's definitely minerals associated with them. Another interesting thing, a lot of critical minerals are present in geothermal systems, so in the hot brines. So that's another area that the Department of Energy is interested in, recovering critical minerals, but they may also be present in the hot brines associated with oil and gas systems. Many of the source rocks for the oil and gas are deep water shales, and the organics in those shales get converted into oil and gas. But those shales also contain uranium and rare earth elements, vanadium, phosphorus oftentimes. And so those can also get into solution in, as you produce the oil and gas, you bring out a lot of water associated with them. And so recovery of critical minerals from the produced waters in oil and gas systems is another area that they're particularly interested. So that's going to be part of our project, is characterizing, the metal content in the sediments, and then also the metal content in the produced waters from the North Slope and Cook Inlet oil and gas wells.
Follow up, Rich?
No, that's extensive response. Very nice.
Okay.
Yeah, you just got to put a quarter in and let me go, huh? So the Biden administration, they came out the gate really pretty with a crosshairs on the oil and gas industry. Heard a lot about the fracking and cessation of leasing activities, cessation of offshore leasing, but we didn't hear anything about mining. And there were a number of executive orders that were issued by President Trump about critical minerals and about domestic production and the supply chain. And those have really been left in place and in some cases augmented by executive orders from President Biden. So there's a good recognition that in order to meet these goals here of reducing the carbon footprint and 100% electric government fleet and 500,000 charging outlets by yada, 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 you have to have the commodities. And if we don't want to be reliant on unfriendly or unstable places, then you're going to have to mine them here. And that's been reflected in a couple of the executive orders. And so far, I'd say it's neutral, if not positive, for mining industry. Now, not to say that that's the end of the story, because it seems like on the next slide, the bottom bullet there is personnel is policy, and a lot of people who are being put in place in the Biden administration came from the Obama administration. They're pretty green. There was a list of people in a recent meeting who were just announced as the leadership for the Bureau of Ocean Energy and Minerals, and they were extremely green people. And so personnel is policy, and while the top line policy may not be to have a thumbs down on mining, if you put a bunch of people in there who have that ideology, then personnel could have a significant impact on the policy of the federal government. Another thing that's pretty challenging is the 30 by 30 initiative, and that's an initiative to have 30% of the nation in conservation areas by 2030. And if that were to be the case, then all federal land in Alaska would have to be put into conservation areas by 2030, because they just don't have enough federal land otherwise. So that's a pretty scary thing from my perspective for resource development. Unfortunately, that's kind of a negative slide to end on, but that's the last slide. So I'd be happy to answer any questions.
Okay, well then I will open up the floor. Steve, again, it was a great presentation at the Chamber, and it's been a great presentation again. So I just wanted to thank you right at the top. Yeah, this is a good slide to marinate on. Do we have any questions? Mr. Dodson?
Steve, Jim Dodson, you talked a little bit about a strategic mineral initiative at UAF. Can you expand on that? Bring it into the discussion, who's the decision maker?
Yeah, so it was a thought, is an idea, and it was a suggestion. And so that was included into our response to the Department of Energy. And I think it's hard to say if it's going to go anywhere or not. It's just, you have to put those things out there for people to think about. I think it's I don't know if Julia has reached out to the folks at the university. Julia and I talked about this as I brought it up at a presentation I gave on our to the AMA a few months back. as an idea. And, you know, some people like it and some people don't. I would say as a decision maker, I don't know who the decision maker in the Department of Energy is. Up at the university, the people I worked with were Paul Lair, who's the vice president, I think, and then Brent Sheets, who's the director of the Petroleum Development Laboratory, and then Dean Schnabel of the engineering department of the College of Engineering and Mines have all kind of been in the loop on that. You know, I just don't know if it's going to go anywhere or not. It's a good idea, but again, you know, in the current state's fiscal climate, I'm not sure how wise it is for the state to be picking something like that up. But, you know, if we can get the federal government to fund it, you know, they could be doing research that won't just benefit our own mines, but mines all across the country.
Follow up, Jim?
No, thank you, Steve.
Okay, again, the floor is open. All right, then I'll jump in. So as I see it, several years ago, FEDC worked on a biomass coal natural gas to liquid project. Now, at the time, that coincided, coincidentally, because we didn't know this when we first started, the federal government was kind of taking a renewed look at coal, natural gas to liquids as a strategic initiative. You know, the remembrance that, you know, during, say, World War II and during the apartheid era, you know, when you had regimes that were limited on their oil supply, that they had found ways to produce distillate fuels with their other resources, but they didn't follow through. You know, I think the strategic dream for the U.S. government was to maybe have a couple of, you know, of these facilities ready to rock and roll if they needed them, but they never followed through. It seems to me that really a critical piece to all of this is the refining capacity within the United States. Would you agree?
Yeah, I think so. You know, if you have to send your ore to Korea, then obviously to be smelted and then somewhere else to be refined, and then before it comes back to the United States, obviously there's a couple of links there that are pretty easy to break. And having a domestic smelting and refining capacity is pretty key to having a stable supply chain.
So I do wonder, after the federal government's willingness to follow through. Yeah, you do have to kind of wonder about that, especially with the seesawing of administrations. The big, to me, one of the interesting things is the interplay between federal policy and free market. Because right now we are in this situation because the free market is such that it is, you know, more beneficial to have those smelters and refiners offshore than it is onshore. And so here we're in a situation where we have a shortage of these reliance on imports. And if we don't want to have that reliance on import, then we have to interfere in the fluctuations of the free market somehow. And, you know, there's people who are okay with that, and there's people who aren't okay with that. But how is that done in a way that makes sense and actually has a positive outcome that you want? I don't have the answer to that. Jim, anything? Okay. Well, I would open it up one more time. All right. Well, Steve, Mr. State Geologist, thank you so much for this presentation. I will say, just a personal anecdote, there on the first floor of the state capitol, when you step off the elevators, there's a giant map of Alaska. as well as a display below it of samples of minerals. And really what it is it's a resource map, so it shows all of the, it's not as detailed, of course, as what you presented, obviously, because it's old. But I actually spent way too long as a staffer just kind of standing and staring at that map as both a kind of example of our potential as a state, but also to a degree of, kind of lamenting that we haven't moved forward as vigorously as one would hope on capitalizing on that potential. But I think the resource, certainly the web-based resource that you've created, making public and available that geologic information is amazing. And so it's good stuff.
Yeah, thanks. Yeah, we, from my standpoint, getting the information is the critical step that we have, I guess, not done as aggressively or as completely as we should have. And, if we had more data available, there would be more people here using it.
All right. Well, do you mind stopping your screen share, sir?
Not at all. Just got to figure out how to do it. There we go.
All right. Well, again, Mr. Masterman, thank you so much for this presentation. It's just very much appreciated. All right. Well, everybody, I think that's our show for today. Just in time for me to go testify in Senate Finance. Much appreciated. Let's see. I don't have anything fully lined up for next week, but of course I'll be working on it and I'll let everyone know. And that's it. So much appreciated. Do you want me to make an announcement regarding the assembly, sir? No. No. Okay. All right. Well, then everyone, again, thank you for joining us, and we'll see you next week. Bye, everybody.
Roger.